Assalamualaikum and a very good day class. So now in week 13 part 2 video, we'll go ahead to the full range Fourier series but different example. At the end of this topic, you should be able to determine the full range Fourier series. And then let's recall back the function of the Fourier series is given by this function. Whereas here we have A0, AN, and BN. Once the question asks you to find the full range for the series, means that first you need to find the coefficients of A0, AN, and BN, which are given by all these formula. Once you got A0, AN, and BN, you can substitute in these functions to get the full range of Fourier series. I repeat again the important part, which is this one is based on the sine function. Then sine negative n pi and also sine n pi equal to 0. Doesn't matter what is the values of n. And then for the cos negative n pi, it is equal to negative 1 to the power of n. And same case for the cos n pi, it is negative 1 to the power of n, which is n here 1, 2, 3 up to the infinity. So now we go to this example 2. The question asks us to find, the question gives us the following periodic function, that is ft equal to t for t in between 0 and 2, and ft equal to 2 when t in between 2 and 4. And here there is some mistake here, class. This one it should be 4. Whereas ft equal to ft plus 4 means that here our period, okay, that is capital letter of t, is equal to 4. And then the question asks us to sketch ft over negative 8 and 8. The first question, you need to sketch a graph of this ft. And then the second question, you need to find its Fourier series. Let's start to answer the first question. In class, we have the function ft equal to t for t in between 0 and 2. And then it is equal to 2 when t in between 2 and 4. So how to plot this graph? We have here, this is our ft, and we know that ft equal to t, this one is a linear function that is in between 0 to 2. The function of ft equal to t, that is, we can plot here when t equal to 0 means that ft also equal to 0. And then when t equal to 2, ft also equal to 2. Let's see, this is 2. So when we plot, we'll got here the straight line. And then for 2 to 4, we'll have here the graph also a straight line here. But it is, because it is equal to 2, means that the graph for all t values in between 2 to 4, it is equal to 2. And then class, when we plot here, because the question asks us to plot for t in between negative 8 to 8, the graph will repeat because our period is equal to 4. Means that here, it will repeat. This one is 6 and then 8. Okay, you will got here a straight line like this. And then 6 to 8, it repeat the same pattern of this one. And for this negative 8, we will have here negative 2, negative 4, negative 6, and then negative 8. Means that negative 8, again this one, it will be like this. And then go to this one will be straight line. And then it will repeat like this and then go to this straight line. Sorry, it should be 2. Okay, all this should be 2. Okay, this one will be straight line. So roughly, this is a graph for this function. So now class, we have answered the question A. We want to solve a question B. That is, the question B asks us to find the Fourier series. To find the Fourier series, understood that first you need to find the coefficients of A0, AN, and also BN. Let's start with this A0. A0, the formula is given by, we have here 2 over t, and you need to integrate. To ensure that it is to integrate here, the limit for this integration actually is from 0 to 4. Based on the question, because we have ft equal to the function of t for the domain t in between 0 and 2, and 2 for the domain t in between t and in between 2 and 4. So in this case, the limit of the integration is start from the value 0 up to 4, and the period here is 4. So in this case, we integrate the function of ft dt. So we have here 2 over 4 over period, which is 4. Integrate 0 to 4, and then we have here the function of f dt means that we have 1 over 2. We integrate start from 0 to 2 first. When we have the limit 0 to 2, the function for ft is t. So we integrate t dt plus integration 2 to 4. The function here is 2, so 2 dt. In this case, it's simple to solve this integration. We have 1 over 2, and this one is t squared over 2, which is start from 0 to 2, plus 2t, which is start from 2 to 4. When we simplify this one, we'll have here equal to 1 over 2 times 2, and then plus this one 2 times 4 minus 2 times 2. So we'll have here equal to 1 over 2 times 2 plus here 8 minus 4, which is 4 divided by 2. So we'll have here equal to our A naught equal to 3. And then class, we need to find A n. How to compute A n? A n, the formula is given by equal to 2 over period, which is 4. We integrate 0 to 4. That is the limit of the function. And then here, the function f of t need to be multiplied by cos and omega t dt. Here, what does it mean by this omega? Omega refers to the angular frequency, which is given by 2 pi over t. Equal to 2 pi over 4 means that it is pi over 2. Here when we substitute, we'll have here 2 over 4, or I simplify this one is 1 over 2. I integrate start 0 to 2, and ft is given by the function t. For 0 to 2, you multiply by cos and omega. So here we have cos and pi over 2t dt plus integration start from 2 to 4, 2 cos, this is 2 from the function ft, and pi t over 2. If you see this one, for the first function here, you need to use integration by pi. For the second function, we can solve it directly. So here class, when we solve for the first function, okay, we have here integration by using integration by pi, integration u dv equal to uv minus integration v du. So when I want to integrate t cos n pi t over 2 dt, in this case, I let here u equal to t, so du equal to dt. And then dv equal to cos n pi t over 2 means that here when I try to find here v, I need to integrate this one, okay, this one, cos n pi t 2 dt. So v equal to, you need to integrate cos n pi t over 2 dt. By integrating this one, we'll got here integrating cos n pi t over 2, you got sine n pi t over 2, and then you have to differentiate inside here, means that we divide by n pi over 2. What we got here class, okay, I write here, I will got u v, which is t multiplied by this v, that is sine n pi t over n pi sine n pi t over 2, this one over 2, and then all this divided by n pi over 2, and then minus integration of sine n pi t over 2 and all this divided by n pi over 2, because this one integration v du and du is dt. And then for this one, we have to integrate this function. Okay, when we continue here, I write again. We have integration t cos n pi t over 2 dt is equal to, based on previous, we have here, if we simplify, we have 2t over n pi sine n pi t over 2. Okay, and then minus here 2 over n pi. I actually factorize the constant part, and then I integrate sine n pi t over 2 dt. To integrate this part, I will have here, okay, so I write this one again, 2t over n pi sine n pi t over 2 minus 2 over n pi, and this part we integrate sine, we got negative cos, so negative cos n pi t over 2, and then all this divided by n pi over 2. When we simplify here, we will have 2t over n pi sine n pi t over 2, and this one we can simplify. Okay, this is minus minus, negative negative, so it becomes plus here. This one we move up, so we have here 4 over n pi to the power of 2 cos n pi t over 2. And class, remember that we want this is just the first part of an, and an, if we substitute all this to an, we have here 1 over 2. We integrate previously from, actually this one 0 to 2. So all this, okay, 1 over 2, you need to multiply with 2t n pi sine n pi t over 2 plus 4 over n pi square cos n pi t over 2. And then if you still remember, in our an, we have this term. Okay, we are not yet integrating this term. If we integrating this term, we'll got here plus, you integrate cos, you will got sine. Instead, you will have here cos n pi t over 2. You divide by n pi over 2, but I move it up here, so I will multiply by n pi over 2, and this one is start from 2 to 4, and this part class, it is start from 0 to 2. So now we substitute the value 0, 2, 2 and 4 in our t. Okay, when we did this one, we will have here an equal to 1 over 2 multiplied by, you simplify, you will got here 2 over n pi, you substitute with 2, so you got here 2 sine 2 pi 2 n pi over, and then here plus 4 over n pi square cos n 2 n pi over 2, and then minus here 0, okay, because we have that one 0, and then minus here 4 over n pi square cos 0, okay, and then we have plus 2 over n pi sine n pi, which is here 4 n pi divided by 2, and then minus 2 over n pi sine 2 n pi divided by 2. In this case, sine 2 n pi, if you use your calculator, doesn't matter what the value here, you can cancel out actually, okay, because this one is a bracket all. Sine n pi, it will tend to 0. And then, all same here, 1, this is 2, sine 2 n pi also will tend to 0. And then for this one also, it will tend to 0. And for the cos 0, it will tend to 1. Means that here you will have, after simplify this one, we can cancel out. We will have here equal to 1 over 2 times 4 over, because this one already 0, this one actually 1, this one already 0, and this one 0. So 4 over class, when we simplify this, we'll got here 1 over 2. And then this one, okay, multiply 4 over n pi square. And then cos n pi. And then minus 4 over n pi square. That is equal to, I can factorize this 4 over n pi square. I will have here 2 over n pi square cos multiply by cos n pi minus 1. And then class, if you want to find the pattern of this series, you need to form a table. Okay, previously we have here an equal to 2 over n pi square cos n pi minus 1. So when I form here a table, I have here this one n, which is 1, 2, 3, 4, 5, and so on, because this an is 4 and equal to 1, 2, 3, and so on. And then the an term here, you can write. Then we have the answer, okay, for the an for each n. Let's say when n equal to 1, we'll have here 2 over pi square cos pi minus 1. Okay, and in this case, cos pi, it is equal to, this cos pi is negative 1. So we'll have 2 over pi square negative 1 minus 1. That is equal to negative 4 over 1 square times pi square. I will mention next why I write this one as 1 square. And then when n equal to 2, we will have here 2 over, remember n equal to 2, so 4 pi square cos 2 pi minus 1. In this case, we will have cos 2 pi, actually it is equal to, this one, it is equal to 1, so you will have the 0. And then when n equal to 3, we'll have 2 over 3 means that n 3 to the power of 2, so 9 pi square cos 3 pi minus 1. In this case, cos 3 pi, it is equal to negative 1. So I have here 2 over, I can write this 9 as 3 to the power of 2 pi square, which is multiplied by negative 2. So negative 4 over 3 square pi square. And then class, when n equal to 4, actually for this case, when n equal to even number, I get 0 for this function. That is 2 over 4 square pi square cos 4 pi minus 1. In this case, cos 4 pi, actually it is 1. So 1 minus 1, it is 0. And then for the fifth term, that is n equal to 5, we have here 2 over 5 square pi square cos 5 pi minus 1. So in this case, cos 5 pi, it is equal to negative 1. So I will have here negative 4 over 5 square pi square. To conclude here, for our an, we will have here an equal to, if you see, it is n to the power of 2, n to the power of 2, and n to the power of 2. To make it general, an equal to negative 4 over n square pi square, because this one is n, so we can write as n square pi square. For n equal to 1, 3, 5, and so on. Okay, and then an actually equal to 0 for n equal to 2, 4, 6, and so on. This is how can we compute an for this function. And next class, we need to compute bn. It is not yet finished. Now class, we will find the bn. Bn formula is given by n equal to 1 over 2 multiply with the integration start from 0 to 2, and we have for range 0 to 2, the function ft is t. You need to multiply with sine n omega t which is here our omega is pi over 2, is that sine n pi over 2 t dt plus the integration 2 to 4, which is we have 2 for the function of ft sine n pi t over 2 dt. So to find Bn, you have to solve the integration. Here, you can see the same pattern as a cost function, and for this part we need to use integration by part. To solve this part, you can integrate directly. To use integration by part, let's say I just pick this function, okay, this integration, I will have here 0 to 2 d sine n pi t over 2 dt, whereas when I integrate here, I need to let u equal to t, so du equal to dt, and then dv we let equal to sine n pi t over 2 dt. To solve means that to find v here, I can integrate this function, means that integrate sine n pi t over 2 dt. That is, integrating sine function will got here negative cos n pi t over 2, and then you have to differentiate inside here, that is we divide by n pi over 2. To simplify here, we will have negative 2 over n pi cos n pi t over 2. So class, when we apply integration by part to this function, it is this integration equal to uv. So this is our u and this is v, means that negative 2 over n pi t cos n pi t over 2. This is u times v. And then minus the integration of negative 2 over n pi cos n pi t over 2 du. Du is given by dt. So now we have here dt. And then we need to integrate this part. By integrating this part, as you will got here, this one we got negative 2 over n pi t. I write again this part. Cos n pi t over 2 plus here, I move this one outside, so I have 2 over n pi. When we integrate this one, cos n pi t over 2, we'll got the answer here, sine n pi t over 2, and then we need to differentiate inside, and then this one we have differentiate inside here n pi over 2. And when we simplify this part, we'll have the answer for this integration, negative 2 over n pi t cos n pi t over 2 plus this one, I move it here, I will got 4 over n pi square multiplied by sine n pi t over. Remember class, what we solve here just for this part. So we have another part here. When we solve this part, you will have this Bn equal to 1 over 2 multiplied by negative 2t over n pi cos n pi t over 2, and then plus with what we have solved previously, 4 over n to the power of 2 pi square sine n pi t over 2, which is the limit for this integration start from 0 to 2. And then this one, we plus with the integration of 2 to 4 to sine n pi t over 2 dt, means that when you solve the second part, you will have negative 2 cos n pi t, which is this one divided by 2, and then we need to differentiate inside here. Okay, so it's divided by n pi over 2, which is this one. It is the limit start from 2 to 4. And then class, we can simplify this one. You will got the answer when you substitute 2, 0, and also 2, 4 in this function, you will have your Bn equal to 1 over 2. And then we have this one, negative 2 times t is 2. So negative 2 times 2 divided by n pi, and then cos n pi, because our t equal to 2. So we can cancel out this one. And then plus 4 over n square pi square sine also n pi. And then minus plus the lower limit here, minus here negative, so plus. But remember we have this t means that here plus 0, because 0 times all this equal to 0. And then plus here minus 4 over n to the power of 2 pi square, okay, sine 0. And for this part, you will have here, this one I can move up. I will have minus 4 over n pi cos our t is 4. So we have here 2 n pi, and then minus, and then minus. So we have plus here because now we go to the lower limit. 4 over n pi cos n pi, because our t is equal to 2. So class, when we simplify this one, we'll got, actually for this sine n pi understood it is 0, sine 0 it is 0, cos n pi here we have negative 4 here, plus this 4. So we can cancel out this, means that our final Bn here, this 1 over 2 times this, so you can, actually this one become 2, we have negative 2 n pi cos 2 n pi. And then class, we need to find the pattern of the Bn. We form a table here, which is we have a table, this is n, and then this is our Bn, and the answer for this Bn, when n equal to 1, we have Bn negative 2 over n pi. So negative 2 over, our n is 1 over pi, cos 2 n pi. So cos 2 times 1 times pi, we have cos 2 pi. And understood, when this 2 pi, it is even number, you will got cos 2 pi will be equal to 1. So the answer here, negative 2 over pi. When n equal to 2, you will have negative 2 over 2 pi, and then cos 4 pi. And this cos also equal to 1, so you will have negative 2 over 2 pi. And then when n equal to 3, negative 2 over 3 pi cos 6 pi. So this one also 1, means that we have negative 2 over 3 pi. And then when we go to 4, we have negative 2 over 4 pi, which is n is 4 cos 8 pi. That is this one, negative 2 over 4 pi. And we can see the pattern here. Our Bn has a pattern of negative 2 over n pi for n equal to 1, 2, 3, and so on. So class, based on this, we need to form a Fourier series. Remember that the previous solution is, we have here, okay, our A0 is equal to 3. A0 is equal to 3, and then we have our An equal to negative 4 over n square pi square when n equal to 1, 3, 5, and so on. And then An equal to 0 for n equal to 2, 4, 6, and so on. And then we have solved for Bn, which is Bn equal to negative 2 over n pi for n equal to 1, 2, 3, and so on. Means that when we substitute in Fourier series, the Fourier series, before that class, we have angular frequency, we have solved previously, which is pi over 2. And our Fourier series ft equal to a0 over 2 plus the sum of n equal to 1 up to infinity, an cos n omega t plus bn sin n omega t. And then class here, for this an, when we substitute this function, this an, and we substitute this bn, finally you will got the Fourier series for this equation is we have equal to our a0 is 3, so 3 over 2 plus when n equal to 1 we use this one which that is -4. We can write over pi square, we put in a bracket here cos our angular frequency is pi over 2 and n is 1, so pi which is pi t over 2. And then next plus which is for even number it is 0, so we don't have to write. When we have odd number 1 over 3 square means that -4 we already factorize outside, so 1 over 9 as 1 over 9 which is time here cos 3 pi t over 2, okay, and then plus 1 over 25 cos 5 pi t over 2 here over 2 plus dot dot dot, and then next minus 2 over pi, and in this bracket it is sine pi t over 2 plus 1 over 2 sine pi t, and then plus 1 over 3 sine 3 pi t over 2 plus 1 over 4 sine 2 pi t and so on. So class, this is the final answer for this Fourier series. I will show you one more example in week 13 part 3 video. Thank you class for your attention. See you in the next video.